Today's topic is about our temperature control of hot or cold reservoir. So far what we have seen about an pick and place robot and automatic washing machine. Okay. So, here we have to see about an what are all the index arena. We have to see about an introduction, temperature sensors, temperature measurement and control, alarm and safety, boiler's temperature control, and need of temperature measurement. Okay. So introduction. So whatever the process or the parameters, that is, that we'll be considering a temperature, flow, speed, for example. Okay. So this is the principles of controls. They are similar ones. Similarly, the input and output signals are specified as appropriate to the application, usually analog, that is thermocouple signal input, solid state output power control, but these may be digital ones. Okay. So when you are saying about temperature controlling or the temperature measurement, or we'll have a temperature control. So there is we are seeing about an how the temperature control of quarter volt reservoir. So in temperature controlling, we have to consider the two things. One to be the temperature measurement, and other one to be the temperature control. So what are the temperature measurement sensors? So when we are seeing about a temperature measurement sensor, so we'll have about an uh, that is thermocouple. We'll have about an thermocouple. So when we are saying about a thermocouple, actually we'll have a three temperature measurement sensor. So one is to be the thermocouple, and other one to be the platinum resistant platinum resistance thermometer, and other one to be the RTD. So when you are saying about a thermocouple, actually it is an electrical device which is consisting of two dissimilar electrical conductors forming an electrical junction. So we'll have a forming an electrical junction. So the thermocouple which produces a temperature dependent voltage as a result to feedback effect, and similarly this voltage can be interpreted to measure the temperature. Okay, and similarly, when you're saying thermocouples, they are inexpensive, interchangeable at the same time, and they are supplied with the standard connectors over on it. Okay, the next thing we have to see about an platinum resistant platinum resistant thermometer. So when we are studying about a platinum resistant thermometer, so actually when you are defining a platinum resistant thermometer, so it is a piece of a platinum wire. It is a piece of a platinum wire which determines the temperature by measuring its electrical resistance. By measuring its electrical resistance. So it is defined as a, it is referred to as a temperature sensor. So when manufactured carefully, so these devices offer an excellent combination of sensitivity, range, and reproducibility. Sensitivity, reproducibility. And the last one to be the RTD, that is about an RTD thermometer. So that is the relative humidity transmitter. So what is relative? So that is the resistance thermometer. So when you are saying about a resistance thermometer, so we'll have a, they are also called as an resistance temperature detector. So they are the sensors which are used to measure the temperature. And similarly, many RTD elements which consist of a length of fine wire wrapped around the ceramic or a glass core, but other constructions they are also used over on it. So the RTD wire is a pure material, typically platinum, nickel, or copper. The material has an accurate resistance or temperature relationship, which is used to for an indication of a temperature. As RTD elements are fragile, they are often used in proactive steps. So the next one we'll have about an temperature measurement and control. The first temperature measurement and control we'll have about an open loop system, and the other one to be the closed loop system. Okay, so we'll have a open loop system and closed loop system. When you are saying about an open loop system, we'll have a temperature temperature measurement, and closed loop system we'll have a temperature control. That is the inputs that can measure thermocouples and resistance temperature detectors, and even DC voltage or milliamperes outputs from temperature sensors or transmitters are a standard requirement over here. And similarly, the thermocouple sensors, they are commonly used available variety of types and configurations to handle almost any application. So this is about the temperature measurement cool systems over on it. Okay. So in the temperature measurements, so thermometers are designed to be totally immersed in the fluid. So they are measuring with the control. So it is possibly we can use the glass tube. So we'll have a furnace thermostatic or manual switch. So here the indicator which is around 600 degrees Celsius, and we'll have an analog output with the recorder. So this is the thing. So when we'll have a alarm and safety also. So in case of over under temperature occurrences, they should never be relied upon for plant safety. So if there is any possibility that component or sensor failure could result in heating part being permanently applied instead of regulated, then a completely independent over temperature alarm should be utilized. So this is the temperature control system with independent alarm. So we'll have an alarm operator path switch normally on and off in alarm position. So we'll have a over temperature alarm unit. So we'll have analog output and control output. We'll have a power switch. We'll have a furnace. So we'll have a over on it. Okay. So this is with respect to with independent alarm. So we have a boiler temperature controller also. So we'll have a three different types. One to be the single acting, second one to be the dual acting, and third one to be the triple acting. So in boiler temperature control, when you action that single acting, so we'll have a high or low limit function. Dual acting will have a high or low limit function. Triple acting, we have a high limit function, low limit function, and we'll have a circulator function. So another one more thing we'll have about an limit switch. So the boiler temperature control, which acts as the limit switch. So we'll have a low temperature different, that is the low limit and the low terminal. Similarly, high temperature, high limit, and the high temperature limit over there. Okay. So in order to maintaining the low limit, we'll be using the blocks which is to be temperature which falls below the low limit, and we'll have a burner turns on. So we'll have a off pathway. We'll have a temperature results to be, so burner turns off, so you'll have a one of them. Whereas for maintaining higher limit, so temperature falls below high limit differential, so we'll have a burner on. So heat call satisfied, so we'll have a high limit temperature reach, burner and circulator off, and burner off over there. So circulator function, so maintaining low limit temperature, thermostat calls for heat, so burner and circulator are on. So heat call satisfied, burner off and circular off, high limit temperature reached, burner off over there. Why we require temperature controller? So we'll have a proper functioning, we'll have a corrosion and wearing, we'll have a safety and effective efficiency. So by that, the temperature of an control or healed hot or cold reservoir gets over. Okay, so the remaining that we can see in the next.